Hello, good morning everyone. My name is Pradeep. Uh, a very warm welcome to the webinar SolidWorks Premium Unleash the Real Potential. Today we have a very exciting content. We'll be covering a lot of different capabilities, advanced capabilities of SolidWorks Premium. Uh, I hope a lot of you know about the flavors of SolidWorks. SolidWorks comes in three different product line. One is standard, SolidWorks Standard, SolidWorks Professional, and SolidWorks Premium. So today we'll be focusing on what SolidWorks Premium brings to the table. In addition to what SolidWorks Standard and SolidWorks Professional can do, SolidWorks Premium adds a lot of value, in form of different capabilities like routing, piping and tubing, routing electrical, and uh, tolerance analysis, motion analysis, a lot of different kinds of design validation. So we'll be talking about all these different aspects of SolidWorks Premium. We'll be talking about how the users can make the best of the solutions available in SolidWorks Premium. I think we are right on time. What I have today is a content worth of 40-45 minutes, and then we can break for Q&A. Before we get started, I have a couple of poll questions, but I think I'll wait for a couple of more minutes. So this is the agenda for today. As I said, we'll be focusing on SolidWorks Premium. I would like to think about SolidWorks Premium as not just a 3D CAD software, but much more than that. Because it power packs all these different capabilities like finite element analysis at an assembly level, which is a fantastic a must-have for all the design engineers to validate their designs before you release them for production. And then you have motion analysis, using which you can figure out the exact behavior of your designs. And then tolerance analysis, tolerance stackup analysis. It's of utmost importance to get your products right the first time. Without which there will be several rounds of trial and error, and tightening and loosening of tolerances back and forth. We can eliminate all that and get your designs right at the first time using tolerance stackup analysis in SolidWorks Premium. And then we have CircuitWorks, which talks about ECAD to MCAD collaboration. This is very useful for people who are into consumer electronics, like cell phones, tablets, etc. Wherever you have your PCB data, wherever you have your ECAD guys working on separate software, at times it's required that you convert those ECAD data into MCAD. When I say ECAD, I mean electrical CAD, and when I say MCAD, I mean mechanical CAD. So we'll be talking about routing. SolidWorks Premium offers the piping and tubing capabilities inside SolidWorks. This is very useful for people who are into processes and plants and oil and gas, and a lot of different other business focuses. We have routing electrical. Unfortunately, we won't be spending much time on routing electrical. In fact, I know we won't be spending much time on any of these capabilities, because I try to pack up everything into one single webinar. So I might be spending at the most 5 minutes to let's say 7 or 8 minutes on each of these topics. So if you are interested, if you want to know more about let's say a given aspect of this webinar, like let's say you're interested in motion analysis, just drop us an email, and then we'll contact you, and we'll schedule a meeting, or schedule a product demonstration wherein we'll focus exactly on what you need. So routing electrical will be just I think touching base a little bit, not much more than that, because SolidWorks has come out with a new product called SolidWorks Electrical. It's both 2D as well as 3D. So it's a whole different topic in itself. So we'll be just touching base a little bit there. And then Scan to 3D is a reverse engineering solution in SolidWorks where you can import point cloud data, which is and then you can build your solid model from it. I don't have a PowerPoint today. It's just this one slide. At this point, I would like to launch a poll question just to gauge the participation, the kind of audience that we have today. Please, answer this question so that we can move on. I think the first question I wanted to ask was, what is the current SolidWorks product that you're using? Because this webinar was mainly focused on showing the capabilities of SolidWorks Premium. So I would like to know if the users are already using SolidWorks Premium, or if you're in standard professional, this is a real. This will be your first look, I would say, at the capabilities of SolidWorks Premium. But if you're already using SolidWorks Premium, still we'll show you all those different aspects of capabilities of SolidWorks Premium that you might not be aware of or you might not be using currently. I'll leave the poll on for a couple of more, for 10-15 more seconds. Please use your mouse to answer the questions. Okay, I think we have the input. I think most of the users are using SolidWorks Premium, so which is a good thing because I can show you a lot of different capabilities that you can immediately start using. The next poll I wanted to launch at the very beginning, but I'm now thinking to hold it up for some more time. But nevertheless, we'll get started. We'll get started with motion analysis, and then after motion analysis, maybe I'll launch the poll. So at this point, I would like to jump to SolidWorks. So I'll be using SolidWorks 2013 for this webinar, but I guess for those of you who are using 2012 or older, I think you might be able to do pretty much what I'm doing here. So why do we need motion analysis in SolidWorks? Most of the time we build products which have moving parts. So at times it's really important to simulate this motion at the design stage itself, which means without even the product is out or the prototype is out, we need to test the performance and the behavior of the design. So in this case, the data set I'll be using is one of our own customers, Holmatro Inc. USA. It's a spreader rescue tool. It is used to pry open the car wrecks at accident sites. So you can see that it's a hand-driven, handheld, hydraulic-driven design, and it has a couple of jaws. And let's say I want to test out the performance of this design. Ideally, I would have to wait out till the prototype is out, and then I'll take it into the lab and create a test rig or a setup like this where I have clamps, where I'd simulate forces on these faces and try to open the jaws. So here what I'm looking at is a validation or verification. I want to make sure that this jaws can open load up to 220,000 newtons or 200,000 newtons. So as I said, in SolidWorks you can use motion analysis in SolidWorks Premium. You have motion analysis capabilities which will allow you to simulate motion like this. I have already created a study, so I'll just quickly play this. And then I'll create the same from scratch. So this is just to give you an idea of how SolidWorks motion analysis behaves and what kind of results it gives you. So if you look at the setup here, we have a piston actuator and we have a couple of clamp forces. We have contacts defined. We have even things like gravity defined. And you can see that SolidWorks is capable of giving you some engineering data back. Like here, I have plotted a motor force graph. so which will tell me at any given point of time what is the peak motor load on the motor. So based on which I can work backwards and figure out the motor specs. So what I'll do now is I'll create a motion analysis study from scratch. For those of you who are using SolidWorks Premium, you need to have this add-in checked in. We have a window called add-ins when you go to your tools options, and you need to have the SolidWorks motion checked in order to use motion analysis. So when I say create motion study, SolidWorks will give me three options. One is a basic animation, second is a basic motion, and then we have motion analysis, which we'll be using today. As SolidWorks says, this is the most realistic simulation, taking into account all different types of conditions like contacts, gravity, material, etc. So now we'll start a study. So the first, it's an integrated interface, which means you don't have to leave SolidWorks. Everything happens in a single window, and we'll place a virtual motor here. It can be a linear motor or it can be a rotary motor. In this case, we need a linear motor or an actuator. So everything is very simple because you are selecting geometry and you're assigning the directions. In this case, I want this actuator to be driven on the other direction, so I'll just reverse the direction. And I can specify the motion in different ways. I can specify constant speed, I can give it a driving distance. So in this case, or you can even create your own function, but in this case I'll just give it a specific distance, 60 millimeters. So in other words, I'm telling SolidWorks to move this piston actuator by a distance of 60 millimeters over a period of time 5 seconds. So we have created a virtual motor. Now next up, we need to create some forces, opposing forces on the clamps. So reverse the direction and let's specify the constant load of, let's say, 200,000 newtons. And similarly on the other side. There you go. And up next, we'll create some contacts. This is very important because we're telling SolidWorks which are the bodies that are contacting with each other. We can specify material, we can specify friction, or we can even override these material defaults. For selecting, I'll just select this jaw tips in one group and the clamps in other group. So now I'll just override this material defaults. I'll just bump up the stiffness by a little bit and damping by a little bit. So now we have our contact defined, and we can go ahead and specify gravity and other conditions, but I don't think that's required as of now. So let's click on calculate. So when you click on calculate, SolidWorks will go into a virtual study, into a virtual simulation. You can see that it's calculating and displaying results at the same time. At each time frame, it calculates or it simulates the load on the clamps and it tries to open them. SolidWorks motion or motion analysis heavily depends on the mates. So it's very important to have your assembly or setup or your design setup for SolidWorks motion. So you have to be really careful with the kind of mates that you're using, and you can't have many redundancies, etc. So that's a whole different topic in itself. But for now, we have finished our calculation. So what I want to do now is I want to get some real value out of this, some engineering data. So what I can do is I can plot a whole lot of different graphs. In this case, I want to figure out the motor forces. All I have to do is select the motor, and SolidWorks will give me a motor force graph. So at different points, at different time frames, I can figure out what is the load on the motor or the motor force. So you can see at this point, at somewhere between 1.5 to 2 seconds, we have a peak motor force of just under 220,000 newtons. So you can work backwards and calculate your motor specs from this. So again, quite a very useful feature at the design stage itself. If you're able to do all this, which means most likely you'll get your designs right the first time. SolidWorks motion analysis can be combined with SolidWorks simulation, which is finite element analysis. So I'll quickly show you how it's done, or I'll quickly show you what it means. Let's say we have finished our motor motion analysis, and then now we are interested in figuring out the stresses induced in, let's say, one of the components, or if we are interested in the deformation that's happening in, let's say, one of the components. We can use SolidWorks motion analysis in conjunction with SolidWorks simulation. When I say simulation, I mean finite element analysis, linear static. So I have already set this up, so I'm just gonna play the results just to give you an idea of what SolidWorks is capable of. As I said, it's the same setup which we used in the motion analysis earlier, with the exception that now we are going to calculate the stresses induced in one of the components, one of these arms. What SolidWorks does behind the scenes is it calculates the stresses induced, or the deformation, whatever you're interested in, at each time frame. At each time frame, it calculates all these different values. So here, let me quickly play this. So you can see that SolidWorks is plotting you the von Mises stress distribution on the arm at different time frames. So as you saw from the previous study, we had peak forces at this 2 to 3 seconds. So you can see, if you observe carefully, you can see that you can figure out where the peak stresses are happening. You can see that SolidWorks is pointing out areas where you have peak stresses. So if these stresses are very close to your yield limits or strength limits, then you can go back, change your designs, edit your designs, and make them more robust and more stronger. So this is SolidWorks motion analysis. I assumed this was a topic that everybody would be interested in, so I went ahead and started the webinar with this. So let me just quickly launch a poll. As I said, I was waiting for more audience. So now on screen you'll have one poll question. I just wanted to gauge the interest of the audience and different capabilities. I think you can select more than one topic. What I will be doing is I'll be positioning, or I'll be sequencing my topics accordingly. I think motion analysis is already done, so don't worry about it. You can just ignore it, and you can go ahead and select the other topics. So I hope everybody liked what you saw in motion analysis. That's just a primer. Remember, it's just one of the examples, one of the many. It's a tiny speck out of a huge offering of SolidWorks Premium. We have more. Please let us know if you are interested in taking an in-depth look at any of these features. As I said, I have packed 7 or 8 different topics into one webinar, so I'll be not spending more than 5 to 10 minutes on each of these topics. So I think I got fairly decent participation. So let me close the poll, and I want to share the results as well. So you can see that most of the audience is interested in linear static analysis. Then we'll go to tolerance analysis, and then we'll come back to some routing capabilities, and then finally we'll take a look at CircuitWorks. Let me just make a note of it. Okay, so let's move on. I'd like to move to the next topic, which is linear static analysis of parts and assemblies. If you guys are aware, SolidWorks at all levels, be it standard, professional, or premium, offers some or the other level of finite element analysis. If you're using SolidWorks standard or SolidWorks uh, professional, you can do linear static analysis of your parts, of your designs at a part level. But if you have SolidWorks Premium, you can do finite element analysis, linear static analysis at the assembly level. So that's a major differentiator between SolidWorks Professional and SolidWorks Premium. So let me just give you some overview of what we're talking about. The dataset we are using is a bolter from a company called Resumen, one of our customers, and the data set that we'll be dealing with today is one of these hydraulic boom knuckles. It's a knuckle kit assembly which will support the hydraulic boom. So what we are interested in simulating the load, again, like what we saw earlier in motion analysis, but this time we are not going to deal with motion. We are just interested in um, the strength, or verifying the strength of this design. So this is the data set that we'll be using. There you go. And again, like I said, you need to enable the add-in SolidWorks simulation. If you are using premium, you need to check this in order to use SolidWorks linear static capabilities at an assembly level. So first things first, we can simplify designs by getting rid of toolbox components or any other components that are not really going to play a major role in your simulation. And then, as you saw in the design, we have a rod eye component, so I would like to bring in the rod eye component as well. Let me just quickly place it at the center, and then we'll be good to go. Let me fix this at a position where the load would be the maximum. And I think we are all set for moving on to the finite element analysis. So we have your simulation command manager tab, or you have your menu drop down from which you can create a new study. New study. In this case, I have my static enabled. For other capabilities, I think you need to go into the next product, SolidWorks simulation. So for now, we are in SolidWorks simulation mode. Again, SolidWorks is known for its integration, single window integration, so everything happens in the same window. So here in this case, you have a lot of different options. So let's look at all these options. This is a subassembly, and we had material defined already. So SolidWorks simulation will just import all this materials that you have defined in your CAD. So we are good to go. And fixtures, we need to fix this geometry. So I'm just creating a couple of fixtures, and this mechanism or this assembly is free to roll or slide on this wear plates. So I'm creating additional fixtures there. And now simulating the loads. The load I can simulate on this face. And load can be a different types of loads. We have force, torque, pressure, bearing loads. So let's simulate 180,000 newtons. There you go. And and we can just click on this button, run. So SolidWorks will take care of everything else, like creating the mesh, applying the boundary conditions. Everything happens behind the screen, so you are exposed to minimal complexity, and what you are interested in is obviously the results. And SolidWorks has got some of the fastest solvers in the industry. So within no time you will be given the results, like the stresses induced, the displacement, and the factor of safeties. So here we have the results. So you can see where the peak stresses are happening, and how the assembly is deformed. You can even animate this just to understand how your how the deformation is happening. And of course this can be a little bit exaggerated because it might not be to scale. So here you'll get to see where the peak displacement is happening. But when you're dealing with assemblies, you're dealing with parts which are made up of different materials. So a factor of safety plot would be the ideal way to make sure that your designs are safe. I'm creating a factor of safety plot here. Let me hide this simulation symbols. Yeah, so you can see that according to this graph we have a minimum factor of safety of 1.72. We can even point out that exact location. This graph is not very helpful because you have a huge range. So let's redefine it. We'll tell SolidWorks to plot a graph of factor of safety from 1.7 to, let's say, 4. Yeah, so there you go. So now you can see that there's a factor of safety is going below 2, which is not preferred in this case. So let's try to achieve a minimum factor of safety of 2. So for this, we can quickly go back to our model tab where we are in CAD mode. So where we have our CAD geometry, and we can quickly make some changes. In this case, I would edit this part, the main part, the knuckle kit. So let me thicken this component a little bit to just make it stronger, and maybe we can change the radius of this fillet. But you can see SolidWorks used Fillet Expert to add fillets to all these different places, but not a problem. In SolidWorks we can change that, just that particular fillet. We can resize them, and now we have different geometry, so we can quickly come back. So now we have different geometry, and we can quickly run the analysis for the modified geometry, and SolidWorks will come back with the results again, and this time hopefully our factor of safety goes up. So if you have any questions, you can make use of the questions window. You can keep typing in the questions, and we'll get to them at the end of the webinar. So if you look at our factor of safety plot now, the minimum factor of safety now is 2.07. So we have increased the strength of the part by making some quick design changes, and I think this is the power of SolidWorks Premium. You're putting the value, and you can putting the power of finite element analysis into the hands of the designers, and everything happens in the same window, which is extremely easy to use. You didn't even have to go through the mesh and all those intricate detail. What you are interested in, and you should be focused on is your designs. So let's move on. So the next topic I would like to take up is stackup analysis, tolerance stackup analysis. So I'm not going to get into the detail, like what is tolerance stackup analysis and why we need it. That's a very time-taking and whole different topic in itself. So we'll just assume that we all need tolerance stackup analysis, in order to get our fit and function right. So SolidWorks is capable of calculating your stackups at an assembly level, but you need to have SolidWorks Premium for that. SolidWorks Professional Standard do not SolidWorks Professional Standard do not um, support this. Okay, so let's move on. So I have a sheeter assembly here. It's a very simple assembly. You have a couple of rollers, you have a cutting mechanism, a couple of blades. So to get this kind of assembly right the first time is very, very important. Again, as I said, SolidWorks imbibes or includes motion as you keep on building your assemblies. So when you have assemblies like this, when you have your designs like this, it's very important to get them right, get them validated. Here you have a couple of blades, the lower blade and the upper blade. So let's open up this subassembly. So you can see the cutting mechanism here. But if you look closely, we have a small gap of 0.1 millimeters. This is in CAD. All the dimensions in CAD are nominal, but in real life, this dimension will never be 0.1. That's because you have so many factors that you have to take into account. You have geometric tolerances, you have dimensional tolerances, you have your fitting issues, you have a lot of different factors that are coming in. So SolidWorks tolerance analysis, or as it's known in SolidWorks as Tol Analyst, will help you calculate your stackups, which means it will take into account all the different tolerances like geometric and dimensional tolerances into account, and it will give you a worst case and best possible scenario, the minimum and maximum scenario. So in this case, let me just show you how it works. I'll open up this upper knife block, and then SolidWorks we have something called as DIM Expert, using which you can specify your datums. This is at a part level. Again, you can see that as you keep on building your dimensions, if you include all these different tolerances, SolidWorks is capable of bringing them in seamlessly into your Tol Analyst. Typically, people do this kind of stackups in Excel sheets. I highly recommend using SolidWorks or any other tolerance analysis at CAD level, because it's much simpler and it's much faster as well. So here, let's say in this case, we are looking at a push fit. So we can change or we can edit these values at any given point of time. Press fit, sorry, and let's say we have P7. And if you go back to the assembly, what we can do here is create a tolerance analysis stackup study. So for this, you need your Tol Analyst checked in. So we'll create a new tolerance analysis study, Tol Analyst study, and it's a step-by-step, again, a very logical way of doing things in SolidWorks, a step-by-step procedure. It starts by creating, selecting two DIM Expert features to create a measurement. Here, in this case, as I said, we are interested in this particular area. We are interested in maintaining a minimum distance of, maintaining a distance of, let's say, 0 to 0.2 mm between these two blades. The nominal distance is in CAD is 0.1, but we know that that's not going to be the case. It will be, we are good to go if it is between 0 and 0.2, let's say. So we'll start by creating this measurement. All you have to do is select these two faces. And once you do that, SolidWorks will give you a measurement of 0.1. This is going to be our study. And now SolidWorks tolerance analysis, Tol Analyst, needs input like assembly sequence. We need to tell SolidWorks in which sequence these parts will be assembled. So I'll just select the parts in which in the order in which they'll be assembled. First comes the lower knife block, and then the lower blade, couple of guide pins, and then comes the bushings, and then the upper knife block and the upper blade itself. So we have defined the assembly sequence. Whenever you see green, it means you're good to go to the next step. So now SolidWorks needs to know the constraints which are important for its fit. So in this case, we need to select. We would have created so many mates while assembling this part, so we need to tell SolidWorks that which are important. We have primary, secondary, and tertiary constraints. So tolerance list needs information regarding different parts. Here bushing IDs are important, so I'm not selecting the OD. If you want, you can put it as secondary, but that's not required. For upper knife blocks, again we are looking at a press fit. For upper blade, it will be flush. So once we select all these constraints for different parts, the next step, SolidWorks will calculate the tolerance stackup. So in this case, you can see the analysis summary to the left. The nominal dimension between those two blade faces was 0.1, but now SolidWorks tolerance analysis will give you two different types of scenarios. One is a worst case scenario. In the worst case scenario, SolidWorks is telling you that the dimension can vary anywhere between negative 0.075 to positive 0.305. And worst case is usually a pessimistic way of doing things, like you're assuming a worst case tolerances, worst case dimensions and worst case geometric tolerances everywhere at all the parts, at all the dimensions. So it's a pessimistic way of doing things, but at the same time, if you get this worst case scenario right, you'll have no problems with your assemblies. And we have a root sum squared analysis as well, which is slightly more better than the worst case values as expected. So now what we can do is, using tolerance analysis, we can figure out the major contributors. So a particular dimension is contributing to 59% of this deviation. So what we can do is we can tighten the tolerances wherever needed. So I'm changing the tolerance from 0.2 to 0.04, and we can recalculate and see the effect. So now the minimum is 0.005, which is good, and the maximum is 0.225. So now the highest contributor is the upper blade. Again, we can tighten this, or even relax it if not needed. So now we can see that the worst case minimum and maximum are 0.035 and 0.195, which are falling into our expected values. You can see that SolidWorks also gives you a preview of the position of the blade, of both the blades, for minimum as well as maximum. So we can export these results into, let's say, an Excel sheet. And you can share this results with your team. So this is tolerance analysis. Again, a very fantastic way of doing things to get your designs right the first time, to avoid all your fit, form, and function related issues. So let's move on to the next topic. I think the next topic you all wanted to see was routing. So we'll move on to routing. So SolidWorks routing is again very powerful functionality, which is available only in SolidWorks Premium. In routing, we have a couple of different, more than a couple of different ways. We have piping and tubing module, which is for people who are into processes in plants and oil and gas. And we have electrical routing, people who are into control panels and electrical wiring, cabling, wire harnesses, etc. even electronics, consumer electronics, etc. So let's move on to the piping and tubing module first, and then I'll quickly give you a glimpse of electrical routing. As I said, it's a whole different topic in itself. This is a oil and gas kind of setup where you have some pressure vessel designs and some skids, some motors, and some structural frame. Everything done in SolidWorks. So you can see the kind of pipes that are running here between different tanks, between different pressure vessels, and you have walls, you have elbows, you have T's. So quite a detailed setup, I would say. And this is all piping that I'm pointing out. And for tubing, if I get into this control panel, you can see different types of copper tubes running around. This is a tubing module. So in Command Manager, you can see that piping has its own tab and tubing has its own tab. Both work more or less in a similar way. It's just that both are different, separate ways of doing things. So let's do a quick pipe route. I'm using display state to hide off all the other components. I'll be focusing on this area. So I'll quickly create a pipe route between this pump and let's say this pressure vessel. And there are a couple of ways of doing it. One is you can do it manually, or you can use auto route capability. I'll show you both. So let's start the route by dragging and dropping a component. It can be something like a flange. Quickly dragging and dropping a well neck flange, and SolidWorks automatically figures out the right size and adds the mates as well. This is a smart component feature in SolidWorks. And as soon as you accept this route properties, SolidWorks will start the route. Here you're just specifying what kind of pipe needs to be used, what schedule, what kind of elbows should be put in, and if there's any covering, you can add that as well. I'm just accepting the default properties, and SolidWorks will immediately start the route. It will even give you a preview. And you can see that we are in sketch mode. We are quickly in a 3D sketch mode actually. So you can add sketches. This is a 3D sketch, so I'm quickly dragging and dropping. As I keep drawing line segments, you can see that SolidWorks is adding fillets, which are nothing but elbows. So I'll add one more flange. And now I can quickly join these two. And we can even get rid of this pipe if we don't need it. So there are a lot of options, a lot of fantastic options. And as soon as I come out of the sketch, SolidWorks will create the pipe route for me. You can see that it's creating a virtual part in the assembly, and it has picked up the elbows and the pipes of the right sizes. It's a huge time saver. So now what I want to do is I want to edit this route, and I want to, let's say, split the route. And add a well neck flange here. But this is a 3-inch pipe, let's say. So we'll see how SolidWorks will add the route for us. So it started routing a 3-inch pipe. And now I'm going to show you auto route how it works. So all you have to do is select the points. And SolidWorks will give you a warning if there's a conflicting or any existing parts that are coming in the way of it. But the good thing is SolidWorks will suggest you alternate positions. I think this is good enough. So what we can do is we can accept this, and up next what I want to do is I want to add a T. I reduce the T. You can see that SolidWorks added a T, and it has, in this process, it's automatically cut the pipe into the right size for me. And you can see that in this newly created virtual part, it has created folders. One is components and one is route parts. In the components folder, you have all your flanges and other components, and in your uh, flanges and teeth. And then in your route part, you have all your pipes and related components. So now pipes and elbows. So we can even let me quickly split this and add a wall. If you have walls which are frequently used, you can pre-assemble them and you can just drag and drop them. So huge time savers. We can even open up this pipe route in its own window and create let's say a pipe drawing, or add or change anything in here. We have different routing points. This is just a glimpse of one particular aspect of SolidWorks piping. We created a manual pipe by creating a 3D sketch, and then we had an auto route. So different ways of doing things. And as I said, we have tubing as well, which is quite similar. You can use it for your tube routes. Hope it was helpful. As I said, I can't spend too much time on a given topic. So let's move on to the next topic. I think we are falling short of time. So I'll quickly show you the ECAD to MCAD collaboration of CircuitWorks. Again, it's a part of SolidWorks Premium, like all the other capabilities that I showed you today. This is for ECAD to MCAD collaboration conversion. So you can open up ECAD data in SolidWorks. It can be your IDF files, or it can be your EMN file, ProStep files. So what I'll do is I'll quickly open up a cell phone data set. So SolidWorks will seamlessly bring in all this information. Here you have a lot of components, a lot of the complete PCB data. So what we can do is we can look at the preview. We can filter out components. The plated holes, non-plated holes, all are recognized. You have designators, you have outlines, you have annotations. You can filter all this out. And SolidWorks on the feature manager on the left, it even gives you warning saying that this particular component has no height. So we can assign let's say a height to it, and we can even filter out components that are, let's say, shorter than 1 mm. We can get rid of them. The idea is to convert this ECAD data into MCAD. So you can see that SolidWorks has disabled all those different components which were shorter than 1. So now what we can do is we can quickly click on build model. But what SolidWorks does behind the scenes is it goes into this library where you have a physical component, a 3D CAD component assigned for each one of these parts. So it'll just quickly bring in all these parts like ICs, different kinds of chips, resistors, capacitors, and then it'll place them onto this PCB board. So all I have to do is click on build model. So you can see on the bottom, SolidWorks is giving us a status. So it'll build a SolidWorks assembly for us, MCAD assembly for us that you can use. Yeah, I think here, there you go. So if you look at this MCAD assembly, it's a assembly with all your components. What you can do is there are a couple of different reasons why you want to do this. One obviously is to create your plastic component design, the outer designs for this part of the PCB. Second thing is for flow simulation, where you can for CFD modules, where you can figure out the heat transfer, the kind of heat generated, and the cooling optimization required for this kind of PCB layout. You need a MCAD module, so that's what you can do. And this data is can be exchanged bidirectionally, which means if I want to make some changes in MCAD, I can do those things and I can export this back to CircuitWorks. So now CircuitWorks is giving you both the configurations and the differences. We have a powerful compare functionality. So you can see that this was the original and this was the change. So SolidWorks will point out the different areas which have been moved. So it's saying that this component was moved from initial position to this position. So a lot of different things. It's a bidirectional ECAD to MCAD collaboration between SolidWorks and any ECAD software that gives you ECAD data. So I think we are almost at the end of it. If there's any topic that is left, that might be scan to 3D and routing electrical. So let me just talk about scan to 3D. Scan to 3D is nothing but the reverse engineering solution inside SolidWorks, which will enable you to bring in point cloud and mesh data for your solid modeling purposes. So if you guys are using scanners, you'll be familiar with all this point cloud data. So you can bring in these mesh files or point cloud files, XYZ files, or AC files, or even mesh files like nzip, nxm, csn. So you can bring in these files. So let me just quickly bring in one data set. So this is a XYZ file, point cloud data. So this must be done by using some kind of a 3D scanner. And you can build a solid model for this in SolidWorks. So how do you do it? You need to have SolidWorks Premium and you need to have the scan to 3D add-in enabled. What you can do is you can use wizards. We have a mesh prep wizard, we have a surface prep wizard. You can orient this if needed. You can remove the excess noise if you want, and you can delete parts of this point cloud data. Sometimes you'll be using, let's say, clamps, so you can delete this particular data if you don't want it. And then you can simplify your model, and then SolidWorks will automatically construct a mesh. And all this 3D data, initially will be a mesh, and then you have to convert it to a solid by, if needed, by using surfaces. And this is going to take some time, so let me just quickly come back to the PowerPoint. So I think the only topic left, as I said, was routing electrical. Let's see if you have any questions. You can use the questions window. The idea was to finish this in 55 minutes and then have the last 5-10 minutes for Q&A. So please type in your queries, questions, or any doubts regarding the capabilities that we showed till now. I have a question regarding simulation. We have tried using simulation in assembly mode, but we weren't able to run it. Um, as I said, simulation in assembly mode will work if you have a SolidWorks Premium license. So make sure that you are using a SolidWorks Premium license. You can go to help about SolidWorks and it will tell you what kind of SolidWorks license you have. You need a SolidWorks Premium license to be able to run finite element analysis, linear static FEA at an assembly level. Uh, if you're using a premium license, then just get in touch with us and it should be, and our support teams will be more than happy to help you out. And it doesn't matter if you're using 2012 or 13, it's there in both. So SolidWorks has created a mesh that you can use to create your surfaces or and then the solid models. And a very interesting thing here, instead of dealing with the whole model, what you can do is you can split this model and uh, make use of symmetry, leverage symmetry if you have it. So SolidWorks will split this into submeshes. What I'm going to do is further split this into one more half. Excuse me. I have one more question. Is it possible to do a concrete material simulation in SolidWorks Premium? If you mean concrete as a material in SolidWorks Premium finite element analysis, no. As I said, it is linear static, so the material should be linear in nature, which means it's mostly all different kinds of metals which follow the Hooke's law. If we have SolidWorks Simulation Premium, which deals with nonlinear materials like your plastics and rubbers and other advanced composites. But I really doubt if concrete comes into that category as either. So I can use your surfacing wizards to create the model from here on. So since we're running out of time, let me just quickly open to show you some electrical routes. It's similar to your piping and tubing, but instead of pipes and tubes, you'll have electrical wires and cables here. This is a packaging line assembly when this is a pallet dispenser subassembly inside SolidWorks, completely done in SolidWorks. And let me just quickly show you how do you, I don't think we have time to create a route, but let me just show you the completed routes. And while this opens up, let me just quickly move to the next slide. Please mark your calendars. We have a couple of events coming up, one in Pune, one in city of Bangalore. These are the launch events for SolidWorks Electrical. So if you want to get your first look at the capabilities of SolidWorks Electrical 2D and Electrical 3D, please make a note of these dates. And you can email your registrations to info@beacon-india.com. I repeat, info@beacon-india.com. And one more, the next webinar will be on 27th of June. It will be on SolidWorks macros and APIs fundamentals. Again, you will all receive emails regarding the registration, like you always do. But if you want to include yourself in our email invites, please let us know, info@beacon-india.com. I think our assembly is open. Here's my email ID. If you have any questions, if you have any comments or feedback on our webinars, please let us know, and we'll be more than happy to um, get back to you on any queries. So you can see the kind of electrical wiring cables that are running through. All this is created using SolidWorks electrical routing. So for your control panels and for your uh, any kind of electrical routes that you do, you can do it in 3D as well. And this helps you in achieving two things. One is you have unified bill of materials for your mechanical components and electrical components. And second thing is you have all your visualization related benefits. I think that's it. We're at the end of the webinar. So thanks one and all for attending, and please let us know if you have any questions. You can always drop us an email. Thank you.